tips to help with the coin fountain project. So here are just a few problems to kind of help get you thinking about how to set up equations to help you with your coin fountain. Now the coin fountain, what you're doing is you're establishing a parabola, because we've been talking about quadratics in our last unit. And remember, quadratics all quadratics form some type of parabola, and we've been focusing on doing all of our quadratics by hand. We factored, we did quadratic formula, we did completing the square, so we've done all types by hand. And now we're going to bring in the visual aspect, and you're going to see that as you graph this, as you draw it out by hand, and as you use Desmos. So here are a few things just to think about as you design your own equation. Okay, so the first thing that we're going to start thinking about as you design your own equation, here's just a few practice problems here, is this first here, this number right here, the A, this is the number that will stretch or compress your graph, and this is what we've just started talking about. That's going to help determine your maximum, because in a coin fountain, on your coin fountain, so here's the axis, what you're doing is you're designing a water fountain where, like, the water goes up, the water comes down. That's what you're doing. So the A is determining how, wide the water's going. If you want your water to go, straight up and come down just like this, or if you want it to be, taller, like really tall, or maybe you want it to be shorter and wide like this. Okay, the roots, so this next part is determining where it's landing, so where it starts and stops, so where it's going to start over here, or where it ends on one of these places, and those are the numbers on your graph. So in our first example, write a rule for a quadratic function with a graph that has x-intercepts at 0, 0, 4, 0, and a minimum point at 2, negative 1. So where do all of these numbers go in regards to the equation that I've given you at the top? Okay, so this is your x and your y, okay? These are your x-intercepts. So this is like your first x-intercept, this is your second x-intercept, okay? So as we plug this in, so what I'm going to do here is I'm just going to rewrite my equation so you can see exactly where I am plugging everything in. Okay, so our first equation, our x and our y, is going to go here. The negative 1 is going to go right here. And your 2 is actually going to be used in two places. Your 2 is going to go here and here. So that's where that's going to go every time. And we are solving for A. A is what we don't know every time. We're trying to figure out what the stretch is on our graph, or the compression. Okay, so that's where those two numbers go every time. Your x-intercepts, so let me just redo these in red so you can see where the x-intercepts are going. So you've got two x-intercepts, and you're just doing the x value, because remember, this is xy, this is xy, and you only want to do the x, so we're only doing the 0 and the 4. So it'll be minus 0, minus 4. And now what we do is we solve for A. So we'll get negative 1 equals A times 2 times negative 2. And of course, that's going to be negative 1 equals, and then 2 times negative 2 is going to be negative 4. And I'm just going to put my A at the end. And then what I would do now is I would divide by negative 4. So let me go over here. I'm just going to rewrite this. So I would divide by negative 4. And a negative divided by negative is positive. So A is 1/4. Okay? Now, if I rewrite this, because it wants to write a rule for a quadratic function, I would plug it in without, you're basically plugging it in without this right here. So it'd be y equals 1/4 x minus 0, x minus 4. So notice we plugged it in without that 2 and -1. And then you can simplify this because x minus 0 is just x. So it's going to look like this. 1/4 x times x minus 4. Now, this is in factored form. Okay, that's in factored form. If I wanted it in standard form, remember what standard form looks like? That was like at the top, like when we did quadratic formula. Standard form is when everything is multiplied out and you've got your ax squared plus bx plus c. So remember, standard form is this. So you would multiply everything out to get standard form. So this is standard form when I ask for standard form on those directions. Okay, so let's just practice a few more. We'll go through these a little bit quicker now. Okay, so now when we're plugging in, let me just copy this down so you can see where everything's going. Okay, so here is my x and y. So I've got 1 equals, A is what I'm always solving for. And then I've got 2 and 2. There's that x, so that's going to be the same every time. And then here is your x-intercepts. You've got 2 x-intercepts. You've got your first x-intercept and your second x-intercept, and you're only using the x value. So you put your 0 here and your 4 here. Okay? So same x-intercept, it's just going through a different point. So now when I simplify, I've got 1 equals a times 2, times -2. Oh, I was thinking in my head there. So now I've got 1 equals -4a. And if I divide by -4, a is going to equal -1/4. And so now when I plug that in, so you plug it in without doing this. So we've got y equals -1/4 x minus 0, x minus 4. Of course, this is very similar to the last one, except it's just a -1/4 this time. So 1/4 x times x minus 4. And so that's my equation in like factored form. Or this could also be referred to as vertex form as well. So this is also vertex form. Okay. So this one, if we set this one up, so here's my x and y. So I have 8 equals, a is what we're solving for, 4 minus, 4 minus. Here's my x-intercepts. So I have minus a 2 and minus a 6, because remember, you're only using those numbers, okay? So when we simplify, I have -2 here and -2. So 8 equals, we'll get a 4 here, 4a. Divide by 4. And so a is going to equal 2. So when I rewrite my equation, I have 2 times x minus 2, x minus 6. Okay. Oh, this should be a positive 2. And that's going to make this a -4, which makes that a -2. Okay, so glad I caught that. Okay, now let's talk about establishing a good A value. So trying to find a good A value, because I talk about finding a good A value in your directions. Okay, because you don't want some weird value. Now, a fraction can be a good A value, like a 1/2 or a 1/3, a 1/8. You just don't want something really crazy. You don't want some kind of crazy decimal like 0.27685 or, something really crazy. So let's talk about establishing a good A value. So let's say you set your points that you want to get, and this is just an example. Now, I changed this one up a little bit because I want you to think about this. This is a big chunk of extra credit here. So I want you to think about this one. So I've changed it to a minimum on you, and I'm going the other direction on our axis, okay? So let's think about what this looks like on our axis. So first of all, we've got a point at 0, 0, and negative 6, 0. Now think about where the middle is, okay? Now, if it says it's a minimum, it's got to be, you know, let me change to a highlighter. It's got to be, you know, down here somewhere. It's got to be at the bottom, okay? Now, if we're doing a coin fountain, remember, it's got to be at the top. You're going to have to be a maximum. So, and then obviously we're on the other side. You want to do the positive side of the axis. So I'm giving you this as an example. You got to think about it a little bit more. Okay, so we do know, we already know something. We know that our x value here is at negative 3. We don't know what our y value is. Or actually, let me do this down here. We know our x value is at negative 3. We don't know what our y value is just yet. Okay? So let's plug in what we do know. Okay? We don't know our y value. We don't know our a. That's what we're trying to figure out. We're trying to establish a good a. Okay? But this x is the 3. Here are our intercepts. So minus 0 and then negative 6. So if I simplify, okay, because we still don't know what this is yet. We're going to figure it out. And we kind of manipulate that number because it doesn't matter how far down it goes. We're going to kind of manipulate that to make a work for us. So we have a, this is going to be negative 3. This is going to be a positive 3. So now we have a negative 9 over a. Well, we've got to divide by negative 9 right here. So we need some number divided by negative 9. So we can pick lots of things right here that will work, okay? So lots of numbers divided by negative 9 will give us a nice a. So we can make it small, we can make it big. You know, we could pick here. Now, obviously, it's got to be negative. It's got to be something that's negative, okay? Because it's you know, it's down here. But, you know, we could go with a negative 3. That would turn out nicely because then that would give us an a value of 1/3. An a value of 1/3 is a good a, okay? That's not a weird fraction, okay? We could say a negative 6, okay? That would give us an a value of 2/3. That's not an unusual a value. So, you know, that would work. That would be okay. Oops, meant to do an eraser. Oh, that's not going to erase that now. We could even go up to a negative, if we wanted to go to negative 18 and get negative 18 over negative 9. And then that would give us an a value of 2. Okay, so see how you can kind of manipulate that a little bit and work backwards a little bit and design your points so that you can get a nice a. So you can work backwards, plug in certain points, and fix it to where you can get a good a value.